Hello, fellow Grokkers. I'm going to be solving problem challenge 1 in this video, so buckle up. It's gonna be a bumpy ride, and hopefully we'll make it to the other end in one piece. We do not want to develop psychosis halfway through this solve. So, given an array of unsorted numbers and a target number, find all unique quadruplets in it whose sum is equal to the target number. Quadruplets. Are you out of your mind, bud? Okay, so let's first write a output. And what are we doing? We have this array, and target is 1. So we currently output quadruplets, which is an empty array. Now, what are we freaking doing? Given an unsorted array and a target number, find all unique quadruplets. So first thing that stands out to me is sorting. So let's sort. This is your standard ascending sort. Now we have a sorted array. Let's let k equal array.length. Yes, yes, yes. And now let's think. Given an array of unsorted numbers and a target number, find all unique quadruplets within it. So is equal to the target number. All right. Let's start our typical pattern here. So this is a 2-pointer problem. So we have our right pointer and our left pointer is 0. Okay, so what does this mean? So we're going to be, this is the action plan. Left pointer 0. No, right pointer is, so we start on the right pointer, which is 4. Then, no, I is here. Left is 0. Right is going to equal k minus 1. So I is going to go 4, 1, 2, 1, minus 1, 1, 3, minus 3. The left is then going to be here, and right is going to be here. So we're going to start on 4. We're going to go to 1 and minus 3. Ooh, this is weird. Okay, so that works for triplets. But for quadruplets, should I use 3 pointers? But that doesn't make sense. I can't use 3 pointers because that would imply a triple pointer answer. Given an array of unsorted numbers, unique quadruplets. So the first quadruplet this guy gets is minus 3. So how does this guy get the minus 3 in there first? Minus 3, minus 1, 1 at 4. All unique quadruplets whose sum is equal to the target number. Well, I could potentially loop backwards. I could have like a I and a left value, and J and a right value. And say I and J, so we get these two. 4, 1. And then on the other side, we would have 1 minus 3. So what do these things equal? Let's think about this. 4, 1, so that's 5, 6, minus 3 is 3. So we have these things that equal 3, which is not equal to my target. Oh, and I need to sort this stupid thing. Dang it. Okay, minus 3, minus 1, 1, 1, 4, 2, 4. Okay, let's try that again. Minus 3, minus 1, plus 2, 4 is going to equal minus 4 plus 6 is going to equal 2. Okay, so our first thing's 2, our target's 1. And that underline bothers me. So, 2 is too high. Our value is too high. So what if we want to move the right one here? So, we could do that, which then gives us 1. Okay, and then what would we do? Well, I suppose then I would move down to here and move on to this array, basically. And then I would go again, minus 1, 1, plus 2, 4. Equals 0 equals 6. So now we're too high. So we would go... Okay, yeah, so we gotta move this 2 down, which becomes a 1, which becomes a 5, and we're still too high, which becomes a 1, and we're still too high, which this becomes a 2, and we're still too high, and this 2 becomes a 1, and we're too high, and this, well, we can't do that because we're gonna hit this one. So now that's we were too high. Left plus 1. Thinking. What does this equal? 2 plus 6 is 8. So I have 3, 1, minus 3, minus 1, 1, and 4. Oh, okay, wait. 4, 1, and 4, that one worked. And then minus 3, 1, 1, 2. Let's get a little hint. The problem follows the 2 pointers pattern and shares similarities with triplet sum to 0. So I gathered that. We can follow a similar approach to iterate through the array, taking one number at a time. At every step during the iteration, we will search for the quadruplets similar to triplet sum 0 whose sum is equal to the given target. Here's what our algorithm will look like. Well, left is less than right, sum first, second, left, and right. So interesting. Let I equals 0, I is equal to array length minus 3. j is I plus 1 and array length minus 2. Left is second plus 1, and right is array length minus 1. So the way they are operating through this algorithm is they have I, j, left, and right. 1, 2, 3, 4, and then they have 2 empty values. Maybe I could just do R, right? Okay. Then what do they do? Sum is going to be these 4, and if sum is equal to that, then we do left and right. Oh, I see. So basically, I and j are two. Yeah, there are a lot of. Okay. This is a little tricky for my brain to explain while I'm doing it all for the first time, but let's just get this. So, what does this mean? I is going to equal k minus. K minus 1, right? K is the length minus 3. Yeah. K minus 1, and left is going to equal to j. J plus 1. K, j should start at 1 too. Oh no, it should start at I plus 1. Yeah, so I is here, j starts here. Then I is here, j starts here, I is here, j starts here, and then goes here and here, right? Okay, so yeah, wow. What should be I? No, left is less than right. We want to start here and then try and find an array that matches. So if in here we'll say let sum equal to array I plus array j plus array left plus array right. So that's our sum. And what do we want to do? If our sum is equal to the target number, target, is it, oh, it's kids target in here. If sum equals target, find all unique quadruplets. Do we want to return? What are we returning? Yeah, it is an array called quadruplets. Okay. Oh, yeah. Here it is. Quadruplets.push. T2. Yeah, let's just give these all their own names. Do that, and then say push T1, T2, T3, T4. Okay. In which case, left goes up and right goes down. We want to get off our current value. Then, what else? Else, if sum is less than target, what do we want to do? Well, we want to say left plus plus, or else right minus minus. So if we're less than the target, so these are I and j, and then if we are here and we're still less than the target, we'll move left over, or if we're too high or greater than the target, we'll move right here. So what does this return right now? An error. Oh, for this stuff. Now, hey, we returned the right answer. We did it. Woohoo! So that was a bit tricky. That was a bit weird. Not quite what I was expecting. It's the two-pointer design or algorithm pattern is a bit ambiguous because like these are pointers in our array that we're keeping track of, right? Same with left and right. This is a quadruple pointer problem. You know, I guess the triplet problem was a triplet pointer problem. You know, it was a 3-pointer problem. This is a 4-pointer problem. But now it makes sense. The expansion across the array now makes sense in my brain. Like we use these two for loops to loop through, and then we also use the left and right value to experiment with different values. So there it is. There's the whole code at once. Enjoy. This example broke it into like 2 different things, but I didn't really feel like doing that. So here we are. Bye-bye.